Hey, how's it going? So, today we are going to be dealing with Vandermonde's identity. So, if you are taking discrete mathematics or combinatorics, you may have come here and run up into this huge topic, although it's not very huge. Okay. So, in general, we symbolize this identity as by using combinatorials, that is m plus n choose r, that can be written as the summation of m choose k times n choose r minus k. And here, k is the variable that runs from 0 to r. Okay. Now, in order to understand this, we can use the two-back framework. Now, again, this is all whole that I have visualized over the past couple of weeks, that how does this identity really make sense? And it really does. So the framework is basically the two backs framework, sorry. Let's start with the first thing. Let's say that I want to choose so let's say that I want to choose two balls out of three balls. Now, how many ways are possible? The first step that we can do is to choose it manually, right? So if I'll choose it manually, let's say that this is ball A, this is ball B, and this is ball C. So the first combination that is possible is with the ball AB, then BC, then the last one is AC. So a total of three combinations are possible out of this. Second thing that we can do is to apply the direct combinator, that is 3C2. So yeah, so 3C2 can be directly written as 3. So the answer is 3. Okay. Now, in step 3, we will see how we can use Vandermonde identities to deal with this. So according to Vandermonde, what it does is that it divides it into two bags. What do I mean? See, if this is the bag A and this is the bag B. Okay, wait, our ball was A and B, right? Okay, so let this be the bag 1 and this be the bag 2. Okay, this is the bag 1. Let's say that I transferred a single ball A here and rest of the two balls bag B and C here. Now, Vandermonde identity, what it does is that we take this whole bag, both of these two bags as a whole pool. So we are analyzing it as a whole. So I know that it might sound a bit tricky initially, but actually it's not. It's very simple to understand. So basically, right now by the two-bag framework, what I am doing is that I am distributing the balls along the bags to make the to make the combination much easier. So let's say that now I started forming combination. So my first step was looking at bag 1 and neglecting bag 2. So how many combinations of choosing two balls out of one ball is possible? No, it's not possible. So yeah, zero combinations are possible from this side. Now, if I'll see the bag 2 again, once again, same to same in the same situation like bag 1, in the same way how we saw it independently. In the same way, if I replicate this to bag 2 by seeing it independently, I will see that 2C2. So there is a single combination possible at this side. Okay, so at the time when I'm doing 2C2, I am multiplying 2C zeros because I'm neglecting this side, right? I'm just focusing on this side, right? So this will give us a single combination of 1. Now, okay, so now the next process is to interconnect both of these balls. So starting from ball A, if I will connect with ball B, yes, this is possible. And then I will connect with ball C. Yes, this is possible. So this was the okay. So this was the combination 1. This was the combination 2. This was the combination 3. Right. So overall, we got 3 combinations. This is what Van der Waals identity is. So if we see it, then it divided 3C2 as the summation of one ball and the summation of second ball. If we see the statement here, then k runs from 0 to r, right? And what is r? R is the amount of ball that we want to choose. So the amount of ball that I want to choose is 2. So it runs from r. So on the upper side, n and k. So r minus k. This will be n. Now, so if I'll write it down accordingly to the Vandermonde's identity, then the way of choosing two things out of three can be directly written as the sum of I is equivalent to 0 to the amount of choosing, that is 2. So this will be written as, okay, so this left bag is having one item, right? So out of one item, I am choosing I at a single time, and then when I'm going to the right hand side, I should decrease a single bag, right? I should decrease the single item because the amount of items are conserved. If there is 3 and I'm moving towards, I'm moving forward, then it should be equivalent to the same number of items, right? So this will be 2 because there are 2 items on this side, and the total amount of items should be written as r minus k. Now, what is r? R is nothing but the amount of items that we are choosing. So this will be 2 minus I, right? So this is how we can write it down. And in the combinatorial form, we can also write it as simply 1 choose I and 2 choose 2 minus I. Now, some people ask that why do we multiply it? Actually, the multiplication makes sense because the multiplication is one, which is making the combination with A to B and A to C again and again. And again, if we want to understand it more deeply, then we can also choose, we can also check up the very extreme left-hand side. Now, what I mean, let's expand it. So 1C0, 2C2 plus 1C1, 2C1 plus this one will be 1C2, 2C0. Now this will go to 0 because the way of choosing two items out of one is not even possible. So this will become 2 and this will go to 1. This will become 1. So the answer is coming to be 3. Yes. So it's same as 3C2. So I can say that LHS is equivalent to RHS. I know that it might sound a bit messy the way I'm explaining, but okay, so let's see one more example how we can deal with it. So let's say that so let's say that I want to choose 4 balls. I want to choose 2 balls out of 4 balls. I have ball A, ball B, ball C, ball D. Okay. Now I want to choose 2 balls at a single time. So what I'll do is that according to the 2 ball framework, what I have been describing, the 2 bags framework, I will distribute these 2 balls. Let's say that I distributed one ball A, one ball B on this side, and C and D on this side. It's just a choice. It's not that I'm just choosing it to be identical, that it will be 2 and this will be 2. I believe that this is the most best example to analyze Vandermonde's identity at basics. Yes, so at basics, this is the best way. So, yeah, so starting from the very first side, first I will first I will form the combination independently. So from bag one, I am choosing independently combinations independently. So from bag one, the first combination I can see is between A and B, and this can be written as out of 2 balls, I am choosing the number of possible combination such that I can choose 2 balls. Okay, so 2 out of 2 balls. On back 2 again, I have 2 balls. Okay, at this time, out of these 2 balls, I am choosing almost 0. So this will be multiplied by 2C0. 2, say 0. Now on this side, this will be 2C0 because on this side I'm not choosing any ball as it has been already chosen, multiplied by 2C2 because there are two balls total in the bag and I'm choosing two balls. So this is equivalent to 1. So one combination is possible from this side and one combination is possible from this side. So this is the combination 2. This is the combination 1. Now, the independent bag combinations are completed. Now, what I can do is that I can start from A. So, if I will start from A, let's say on this side, I can connect with C. If I'll start from A, I can connect with D. So, AC, AD. So, yes, this is combination 3. This is combination 4. If I'll start from if I'll start from B, I can connect with C and I can connect with D. Now, you may ask that why you're not choosing A, because A has been already chosen at this spot, right? So, combination 5 and combination 6. So, total number of 6 combination are possible. Again, what we are representing, especially the first two expressions, the first two terms that we have formed here, is the very first and the very last part of the Vandermonde's identity. This is very much important to be noticed. So this is the core idea from where Vandermonde's identity is being formed. So basically, one by one, through each and every combination, we can choose to other part. Now, in case if it was about, let us just say like there was one more C, then in that case there was one more probability possibility. Okay, however, we will discuss it in the upcoming example. So, if I want to write it down as Vandermonde's identity, that choosing two balls out of four balls, the summation of C. On the left hand side, I have two balls. On the right hand sides, I have one ball. I is equal to 1. I will start with I is equal to 2, 2 minus I. Why? Because at every time I want to choose two balls only. Right. So this will be I is equal to 0 to 2. So 2C0 times 2C2 plus 2C1 plus 2C1, multiplied by 2C1, 2C1 plus 2C 2 multiplied by 2C0. Okay. So if I will sum it up, this will be 1 and 2C1. This will be 4 and this will be 1 again. So overall, I'm getting it as 6. Yes, so the answer is 6. So this is how we deal with Vandermonde's identity. Now, let's say that there's one more thing. Let's go with one more example. Let's say that I have a total of 5 balls. 1, A, B, C, D, E. Okay. And on this part, I decided to keep 3 balls on the left hand side. So ball A, B, C. And on the right hand side, I decided to keep 2 balls. So D and E. Now this time it gets interesting. So let's first directly apply the combinatorics. Let's say that I'm looking for the number of combinations that are possible to choose 3 out of 5 this time. Okay, so the number of combinations possible to choose 3 out of 5. So how much is it exactly equal? 5 cross 3 cross 4 cross 3, 3, 2, 1. So 2, 2, 2. Okay, so total of 10 combinations are possible. So what if we go for 5C2? So in that case, 5 comma 3 comma, okay, so 5 cross 4, 2 cross 1. Okay. So a total of 10 combinations are possible. Okay. So in this case, you can imagine that if I'm going with two combination, let's just do it manually. So on the left hand side, I am now choosing independently 1, 2, 3. As you know that this will be 3 cross 3C2, that will be equivalent to 3. And on this side, 2C2, this will be equivalent to 1. So total number of 4 combinations we got it from here. So I'm going for 5C2. Okay. So matching A to D, A to E, B to D, B to E, C to D, C to D, and C to E. So basically, C multiplied by 2. Right. On this side, I'm choosing one ball. Okay. So this will be like 3C1 multiplied by. Again, I'm choosing one ball on the second side, 3C1. So 1, 2, 3, 4, 5, 6. 6 from here plus 3 plus 1. Yes, so it's equivalent to total of 10. So this is how Vandermonde's identity helps us in analyzing complex analysis. And we can even go for 5C3 or maybe, okay, so let's just go for 4C3 at last. Let's say that I have A, B, C, and D. Now this time I will keep a single ball on the left hand side, let's say A, and on the right hand side I will keep 3 balls, B, C, and D. Okay, now my target is to choose 3 balls out of 3. I mean, I want to make I want to make combination possible with 3 people. Now, what can I do? First of all, I'll do the independent analysis. That is the very first term of Vandermonde's identity, as you can see here. Yes, this one. This term can be analyzed here. So if I'll do it here, then okay, so basically I cannot see any combination that is possible out of 4C3. Okay, how much is it equivalent? This is equivalent to 4 cross 3 cross 2, 3 cross 2 cross 1, 3 2, 3 2 got cancelled. So we are left with 4. Okay, so total of 4 combinations are practically possible. Okay, so from here I can see 0 combination because practically 1C3 is equivalent to 0. And on this side 3C3, this is equivalent to 1. So I got one combination from this side. Now, let's say this time, although you can start from any side, but okay, so let's start with A. I can pair A with BC, combination 1. So this is like 1C1. I'm choosing one element at a time multiplied by 2. This will be 3C2. So if I will evaluate this, I'll be getting 3. Okay, so the answer is 3. So total number of 3 combinations are possible. So A with C and D, and A with, this time again A with B and D, this part. So overall I got 3 combinations by the multiplier effect. And this shows the importance of multiplication in this property, that why exactly we are multiplying the combinatrix. And this is the reason, because they try to figure it out and attach them to each other. Okay, so if I will write it down, 1C, the summation of 1, okay, 4C2 can be written as the summation of 1C, and this side I have taken 3. Now I is equal to 1, 2, 3, I, 3 minus I. So let's write it down. So I should be equal to 0, 1C0, 3C3. Exactly the thing that we have done here. This is the exact term. Practically, this is the 2-back framework that we have just discussed. So plus again, 1C, 1C1, 3C2. Exactly the same thing what we have discussed it here. Now, as this indices is getting increased 1C0, everything that will come further will be equivalent to 0. Basic sense. So this will be 0 and this will be 0. So this itself is equivalent to 3 and this itself is equivalent to 1. So the answer is 4. So this is how we can represent 4C3 very easily. And overall, this is how Vandermonde's identity connect huge problems into a very similar, into a very easy way, or whatever you want to call it. So overall, if I'll see, then the idea behind Vandermonde's identity is very unique. You can say, like, yeah. So m plus n, choose r, is equivalent to the summation of k is equivalent to 0 to r m k n and r minus k. So according to our back framework, we can say simply that on the left hand back, this is the amount of balls that you are having. And this is the amount of balls that you are having on the right back. And this is on the left back. Okay. And yeah. So overall, if we recall this, then basically out of choosing in the traditional format and directly applying 3C1 and 3C2, we can first divide these elements into different bag. Then we can start making the first independent combination from bag 1 and then from bag 2. After that, using this multiplier effect, when I say multiplier effect, I mean this. This behaves like a multiplier effect and forms the combination with bag B and project each pair, or maybe triplets, or maybe 4 times, or maybe 4 or 5 or n amount of elements, with the m amount of elements on the left on the right hand side. So I hope you got it. It does make sense. So that's all for now. Thanks a lot.